Okay, so where we left off. So I was saying you can break this resultant here, or excuse me, break this vector down into its two components. And I got a new red pen while we were paused. Okay, by just using sine law and cosine law. So, or not sine law and cosine law, sine and cos. So we have an angle, we have the hypotenuse, I can find the y, and I can find the x. If I look at the x first, it's the adjacent side, and I have the hypotenuse, so that would be cosine. So cos theta would be equal to x over the hypotenuse. In other words, x will be equal to 30 newtons times the cos of 36.87. Cos of 36.87. So I think that's 24 newtons. Okay? And then I can do the y. The y will just be sine theta. And it will be equal to the y over the 30 newtons. And so y will be equal to 30 newtons times the sine of 36.87. That's 0.6, so and I think that's 18 newtons. Okay, so if we go back here, then this is 18 newtons, and this is 24 newtons. And once you find the two components, then it's like this hypotenuse isn't here anymore. And so we just take it out. And now what you're left with is a right angle triangle, which you can find the resultant of. Imagine that my resultant actually hits the end. Right? The bottom is going to be 64 newtons. The side is going to be 18 newtons. Square them, add them together, take the square root, and find whatever this is. And find the angle. So 64 squared plus 18 squared. I'm not doing this in my head. The other ones I did, but take the square root. So you get 66.48 newtons. And then you need to find the angle. And it's going east, so it's going to be angle something and then north. And so find the angle, and probably tan would be your best bet, 18 divided by 64. And if you don't round at all, I think you get 15.149, so I'm going to round to 15.5. Excuse me, 15.15 degrees. Okay, and so that's your resultant. So that's one way, which we did often last year, especially if you were not in, if you were in physics first semester. If you were in physics second semester, by then you did know the sine law and the cosine law. But in first semester, we didn't solve anything using sine law and cosine law because you hadn't learned it yet. But I'm just going to go back to my original picture here of 30 newtons and 40 newtons going like this. And I'm going to draw in my resultant. See if I can actually hit the end. It has a little curve in it. Okay, so again, we don't know this, and we don't know this angle. We know this angle down here still is 36.87 degrees. Okay, and so if that's 36.87 degrees, this one is 143.13 degrees. And now that you do know the sine law and the cosine law, you maybe can realize, hey, you could solve this with the cosine law, right? Because you have a side, an angle, a side, and you want an opposite. And we'll get more into this on Monday, but so you don't need this one for over the weekend. But just to remind you, sine law is sine A over A equals sine B over B. And if you want, you could write sine C over C, but we only ever use two sides. To use the sine law, you need a side and its opposite angle. We don't have that here, right? We have a side, but we don't know its opposite angle. We have a side, but we don't know its opposite angle. We have an angle, and we don't know the opposite side. But to use the sine law, you need a pair. And so we don't have a pair here, so it has to be the cosine law. And people always have a problem, remember the cosine law. It's c squared is equal to a squared plus b squared. And that should be easy to remember. That's the Pythagorean theorem. and then minus 2ab cos c. So the way I tell people to remember it is, so it's the Pythagorean theorem, but this isn't quite a right angle triangle, so it can't be the full Pythagorean theorem. It's missing this part, so you have to take something away. So that's the minus. What do you take away? Well, you have two sides, and it is the two sides that you know, and it is a cosine law, so it'd be good if you actually had a cosine in there. Okay, so if you think of it, it's Pythagorean theorem minus the two sides you have times the cosine of the angle you have. So for this one, it would be the cosine law to solve this. So you would do c squared is equal to 40 newtons squared plus 30 newtons squared minus 2 times 40 newtons times 30 newtons times the cosine of the 143.13. And when you do all that and take the square root, you should get back, whoops, don't put your hand in front of the screen like that, 66.48, because you should get the same answer no matter which way you do it, 66.48 newtons. And now you can find the angle, and now you could use the cosine law, or excuse me, sine law, because if this is 66.48 newtons, now you have an angle and an opposite side, and you can find the opposite angle. So you could do sine theta over 30 newtons is equal to sine of 143.13 over 66.48 newtons. And then you would just solve for theta, and it better be 15.15 degrees. Okay, so you'd end up with the same answer. So on Monday, we'll do questions with this. But over the weekend, I just want you to practice using not the sine law and the cosine law, using sine and cos, and finding components. Because really, any vector, no matter how we draw it, any one of these three are really just the hypotenuse of a right angle triangle that is searching for its legs, right? Here's its leg in the x direction. Here's its leg in the y direction. Here's its leg in the x direction. Here's its leg in the y direction, right? You can set up a right angle triangle around any of these guys. Even this one in theory. This one in theory, its x component is whatever it is, and its y component is 0. Right? So something that's going perfectly in the x, it just means it's a very tiny right angle triangle, so tiny you can't see its height, and its y is 0. So your homework over the weekend is actually from your textbook that you were supposed to get today, but you will not be getting today unless you happen to come to school. So I'm going to take a picture of it in a few minutes, but it's these questions right here that I'll take a picture of. And turning the camera. So, and they say things like, resolve the following vectors into their components. In other words, find the x and y. This is the hypotenuse. Create a right angle triangle at this angle. Find the x and y. Now you'll notice for B, maybe, if I could get it clear and hold the camera steady, that it says an angle of 145 degrees. So when you draw that on the Cartesian coordinates, draw in the reference angle, right? Like, so you're going to find you can't make a right angle triangle out of an angle of 145 degrees. So you need to draw it in such a way that you can put, where's my paper? Sorry about that. So that you can put, right? So here's your Cartesian coordinates. 145 would be, well, not quite over there. So this is 145 degrees, but your right angle triangle will be here. And you'll find this x and this y. Okay? So I'd like you to do 1, 2, and 3 for homework for Monday. And I'll send you the picture. And then you have an assignment that you can work on. That's the kinematics. And we can say that's due like Wednesday or Thursday. You can tell me on Monday which day you want to do. But it won't be due Monday. That way, if you want to ask any questions, you'll have a couple days next week. Okay? So I'd say start it over the weekend so that you know if you need to ask, but don't stress about it. So please do these 3 homework questions and have a wonderful storm day.